I am going to try to make an unscripted tutorial of my Minkowski diagram. The curve you see in the chart is defined by this equation over here. In this case, it's set so that the position of the particle follows an arctangential trajectory over time, such that it actually caps out at 3 times the speed of light when it passes through the origin. So it starts off here at slower than light speeds, reaches the speed of light right here, exceeds the speed of light all the way to 3 times the speed of light here, and then slows down back to below light speed. The areas where the particle moves slower than light are in green. The areas where it moves faster than light are in red. Now, if you want to draw multiple curves here, you can do that by putting square brackets around this, and then proceeding to write a comma and including some other trajectory afterwards, always as a function of time. Now, for example, if you want something that's standing still, then you actually don't need the time coordinate. You could just say 0, which could just as easily be 0 times time. And here you have an object that isn't moving. Here you have an object that isn't moving. It's standing perfectly still. This is the new line created. If you want to add something else, like an object moving at 3 times the speed of light, then you just have to write 3 times time. And this way, the object is moving at 3 times the speed of light, just like our original curve at the origin. If you want to include something that follows a more complicated trajectory over time, like say a sinusoidal one, you just have to add another comma and put sine of time. And this will then produce this result over here. Let's say we don't want that. Let's say we want something that changes its curve over time. Say we want something that's first moving at 3 times the speed of light, but then stops doing that and for some reason follows a sine function. If you do that, well, let's delete most of this. Actually, let's leave the original there, just to show off. If you want to do that, what you'll need is 3 times t over here. And you'll have to put the curvy brackets around it, put a colon in front of it, and here you want to define the time range that you want it to apply in. So from 0 to 1, from t equals 0 to t equals 1, the object will travel at 3 times the speed of light, and that's the curve we see right here, the red curve we see over here. If after that you wanted to follow a sine function, you would put a comma and then specify the new time frame, say from 1 second to 2 seconds. And then afterwards, you put a colon and you type in sine of time. Sine of time. And here you have it. For the first second, it travels at 3 times the speed of light. Then for the next second after that, it follows a sine curve. The problem here is, of course, the particle has to teleport from this point over here to this point over here for this to work. To fix this, you need to define this a little differently. You need to add to this the first function minus the second function, which is this one over here. And after that, you need to replace time with the point of transition. In this case, the point of transition is 1. Yeah, at 1 second, the two change. So you replace time here with 1, and you replace time here with 1. You do not replace this one. You do not replace the first one. Now what you see here is that, sure enough, it follows a straight line for a while, and then it starts to follow the arc of a sine function. If we extend the time interval for the second interval, you see it does in fact follow a sine function from this point on. Once you have this in place, you can use U to see what this would look like in other reference frames. And as you can see, in some reference frames, this trajectory sends it back in time temporarily. Sends things back in time temporarily. Okay.